Okay, ignore this load factor thing. It's actually percent full, so implement that function. Here it is, percent full. Oh yeah. I usually do it on both. Okay, let's go see if that's working. Oh yeah, yeah, yep. See how it's not a member of STD? Alright, so it's still 0. Oh, you need a little end line. There we go. Okay. So hopefully once we insert something it'll make sense. Okay. So what do we do first? Right, so we get int index equals hash code. Hey, everyone okay out there?
No.
What's wrong?
Nothing, I'm just not okay.
You're just not okay.
Fine, but later I'll probably be crying.
Alright, so get the starting index. Alright, so that's a starting index. Great. Now what do we do? Okay, so if mtable sub index equals null, if
okay, so when we insert, yeah, okay, the wrong function.
Yeah, so I know what you're trying to do. Think of the first start with the happy path. In table, if it's null, what do? We just
initialize it to a new.
Yeah. So mtable sub index equals new std tuple sub key value and bool. And what are the values going to be? Hey, look, key val and what's bool?
Pony.
The pony.
What's bool? Pony.
And then we return true. Yeah, let's see if that did anything. Well, what else do we actually we got?
Yeah, we have to increment and count and then check for the check.
They didn't like that.
If it's the load is greater than our load factor.
Well, let's first increment and count. And then let's try and fix this C++ error. Error, invalid use of incomplete type tuple. Blah, blah. It is the same error. That's not cool. Invalid use of incomplete. Why is that incomplete type?
Maybe we have to. Is it like an interface where you have to implement a certain amount of those functions?
Yeah, that's kind of weird. Well, let's do it the other way. Since C++ is being annoying.
Is that class overloading?
This makes more sense? Okay. What's that?
I was just wondering why we use the double pointer still. Is it just so that we can get used to it, or?
So if we just create a bunch of them, we would then have to initialize them all. How do we initialize them as? What's the difference between marked and in use? I guess we could just add both. If you wanted to. Is that what you want to do? Sure? Okay, we'll do that. I knew that was exactly. We should then call it node. How about that? With a capital N, marked, and M, in use. So in use means that we've added something to it. Marked means it's been deleted.
Oh, okay.
But yeah.
Because if we don't use the pointers, then we already have the array full of them.
Yeah, yeah, because we're using pointers null as a state. So has been deleted is valid. Actually, we should call it m is valid. Okay, actually is something that's legit, but we want to differentiate between deleted and is valid. All right, so now, oops. So we'll just make it a single one. Node, m table. All right, great. We'll go up here. Node, but we still want to make sure we have everything as is valid as false. Right. There's nothing, and then we can ignore whatever else is in there. It's great. And then dot mtable is valid. We'll go ahead and check that to not. So if it's not valid, then we can make it valid.
So we got have to
Dot m key equals key. Is it m value equals value.
it's about
M is valid equals true. And the last thing we do have to do, what was it called? Do we call it is marked?
marked. We call it marked. And
We just called marked, okay.
and there isn't such a thing as value.
So it's not marked.
It's val.
Yeah, that one likes to count.
What's that?
Yes, you used value, but the parameters val.
Oh, the parameter is val. Okay, cool. All right, see if it compiles. Good, almost there. Is valid. Did you mean m?
Is val.
Oh, up here, right. Moving along, almost there. Has no member is valid. Really, guys? Why don't you just do what I mean? All right, here we go. All right, 0.4. Hey, look at that. So something's working. Okay. All right, so, but is insert correct yet?
No, because we haven't checked to increase the load.
We've also haven't checked if we're overloading something, you know. So a happy path is good. So I'm going to go happy
Wait,
path.
But what if you already have something there?
Yeah, now we're going to go with sadness. So sad path 1 with 2 A's. There we go.
Wait, but we could just not do anything, like return false.
Yeah, see what happens. Load factor 01. Is that correct? Should that be what happened? No. No. I mean, our code, we still want it to be 0.4, but we're resolving to the same location. All right.
So would it be better in a while loop with a variable?
So up here, you actually want to do while m table sub index dot m is valid. One moment. There we go. Index plus plus, right? And then so keep looking until you find something. Although, is that there yet?
Yeah, no, because we need to, like, when it's made, when it goes over the
Yeah.
size, we need to set back to.
Yes?
I think we need to move the ending bracket before dot m is valid. So that.
Oh, yeah,
it's
that
not
would be
setting
cute.
true.
Yeah, whatever. All right. If index greater than or equal to m size, we want index to be what? There we go.
Of course, then if it's full, we do well. it should-
Yeah, look, there it goes. Right.
I guess we could also make it the that modules and
Now sad path 1. Here comes sad path 2. Hope you love my naming scheme. What do you think that's going to do?
It's gonna implement.
Bum, 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 bum.
So it's going to.
All right, hold on a second. So we're going super fast right now. Why is this infinite looping, guys, besides those two people? What's that?
It's always less than 140. rather than 40.
What's less than 140?
The index. Because you haven't incremented the size,
We never increment the size. Why would that cause problems?
right? Because you never go past the size, therefore you're always less than what you're looping through, which is that. Right, it's getting to 40 and then going back to 0, and then 40 and 0.
So we've set the size to what? What do we set the size to? 100. 100. And how many items are we trying to add? Right. Is that a problem?
Yeah.
Yeah,
It
so
has to do with the, if it doesn't know what to do, because we haven't.
right. So once you have 100 guys in there, what's happening to this while loop?
I mean, technically, it's the conditions we set for the while loop. They're technically true.
Right. So while an element's valid, your increment index. If you're at the end, go back to the beginning. If it's full, what's going to happen?
It's just gonna keep moving.
It's just going to keep resetting.
It's going to keep looping around because everything is valid. Yeah.
So we need to like, if
Y'all,
we are,
y'all see what's going on? Yeah. Okay.
if we are at the hash code key percent m size, we need to actually, if we're at the after index plus plus, if we're at the starting key, we need to break and return false.
Okay, yeah. True, we could do it that way, return false. But what we're really doing, remember, this hash table has to implement a load factor.
Yeah.
So since that load factor, by the way, I'm guaranteeing the load factor to be less than 1. Actually, I'll guarantee it's less than 9.9.
I actually just realized that if we do it correctly with the load factor, we'll never have
Correct.
entirely full array.
Correct. The load factor is going to fix this problem for us.
So we just check after adding that if the load factor, if the actual load factor is greater than the load factor we want,
Right.
then we like multiply the size by 2. Well,
If percent full is greater than the load factor,
we create a new array.
if the M table is too full, what do we need to do? So create a new array.
So m size should be increased by 2, and then for each value in the previous array,
Yeah, so then,
insert
yeah, rehash all values into the new array. Use the new array. Delete the old, the old array. All right.
Do we use a pointer for the array right now?
So I'm not going to do that for you, but at least I've set it up.
Alright.
Yep. At least you now know what you need to do. And I've given you some comments and hints about what to happen, what you need to do. And you'll have to still implement remove, which is going to be, well, if you use marked like what we're using here, it won't be that bad. But if you do try and remove from the vector, or the array, you'll be some sadness going on. Okay. All right. Any other questions? Arrow will be. Yes, Richard?
Can I turn my array into a vector?
Yes.
Okay.
We can't.
Oh yeah.
Solid.
I mean, I don't see how it's gonna help other than this one particular case.
Keep in mind, if you call vector.resize, you're going to still need to rehash all your elements. Because it's just going to put the elements in the old locations, which may not necessarily be the correct location where it should be. Y'all understand what I mean?
Yeah.
Good. Excellent.
Which is why I don't think it's even matters that much.
Advantageous? Yeah. Yeah, it's not exactly. It may not be. It's up to you. Hmm?
You've already got the template. Why just start doing vectors and have to modify them? Sometimes,
Well, there's some things vectors will help you. Yeah, you can initialize that. but it may be tricky for other situations as well. But I'll let y'all decide which is better for you. I'm not actually going to say the vector or array, which way is better. It depends on how you wish to code it. Each of them are going to have a couple of tricky things you have to work around. Usually vectors are an all-out win. This time I think they're roughly equal. All right. Any other questions? Nope. All right. Well, we have finishing 5 minutes early. You have plenty of work to get on, and I'll be here. And have a good weekend.